Hey everybody, thank you for joining me. Today we are starting Unit 2, and our first lesson, 2.1, is to use the properties of exponents to simplify expressions. We're going to complete a do now, which is an inquiry activity, which means you're going to look at some math and see if you can sort of develop a rule or look for a pattern. Then we're going to complete some class notes, and I'll give you an opportunity to try some practice problems, and I will model the solutions. Your homework tonight is on IXL. You'll be completing the recommended skills of F8 and F11. I want to remind you that you will get 100% credit if you can work to a mastery of 80% or better on IXL, because remember that the further you go, the higher that you go in your percent, the more points you get taken off for solving problems incorrectly, and that's why we ask for an 80 or better for a percent of practice. So the first thing I'm going to have you do is fill out the 3 squared equals 3 times 3. So I want to remind you that the 2 is called the exponent. The 3 is the base, and you are multiplying the base by itself 2 times. So you're multiplying 2 3's, and when you do that, you have a product of 9. So please take a second to simplify each of the expressions, writing them out in expanded form. In other words, 2 cubed is 2 times 2 times 2, and then 2 squared is 2 more 2's multiplied together, which is 2 to the 5th power. 5 cubed is 5 times 5 times 5, and then you're multiplying it by 4 more 5's. So you have a total of 7 5's, or 5 to the 7th power. And on the last example, x squared times x cubed gives you a total of 5 x's being multiplied together. So if you look for a pattern or see if you can develop a rule, if you look at the exponents on 2 cubed times 2 to the 5th power, if you were to add those exponents, they would equal 5. If you take 5 cubed times 5 to the 4th power, again, if you were to add those exponents, they would be equal to 7. And the last example, x to the 2nd power times x to the 5th power, if you were to add those exponents, they would be equal to 5. So you can see that when you're multiplying and bases are the same, you add the exponents. So same base means add the exponents. All right, if we look at the second example, 2 cubed times 2 squared, well, again, we're going to take our base, which is 2 cubed, and multiply it by itself 3 times. 2 cubed by itself 2 times. So this means 2 times 2 times 2. And in the second parentheses, 2 times 2 times 2, which is 2 to the 6th power. 3 squared raised to the 3rd power is 3 times 3. 3 times 3, and a third set of 3 times 3, which is 6 3's being multiplied together. In the last example, x to the 4th power squared is 4 x's as your base, and that's being multiplied by itself twice. So literally, if you count the number of x's, it's x to the 8th power. So we're going to look for some sort of pattern. And we can see when we're taking the power of power, we multiply the exponents because 2 times 3 equals 6, just like 3 times 2 equals 6, and 4 times 2 equals 8. So we can see where this checks. So when we're taking the power of power, we multiply the exponents. So when we're taking the power of a power, you multiply the exponents. So the first property that we looked at is called the multiplication property. And to multiply exponents with the same base, you add the exponents. And this is the algebraic expression or equation for it. So if we have 4 cubed times 4 squared, bases are the same, so we just add the exponents, or 4 to the 6th power. X squared times x to the 7th power, we add the exponents, which is x to the 9th power. All right, the second property that we looked at is called the power property. And to take the power of a power, you multiply the exponents. And here's the algebraic representation. So 2 to the 5th power squared means 2 to the 5 times 2, or 2 to the 10th power. On the second example, we need to remember that 4 has an exponent of 1. And then we have x cubed, and that whole thing is being raised to the 2nd power. So we're going to multiply 4 to the 1st power times 2, and 3 to the 2nd power times 2. So that gives us 4 squared times x to the 6th power, which we can simplify to 16x to the 6th power. Okay, any number raised to the power of 1 equals itself. So 4 to the 1st power equals 4, and x to the 1st power equals x. So the next thing we're going to do is simplify each expression and leave our answer as a number raised to a power, or an exponent. So remember, anytime you don't see an exponent, it's the phantom 1. So 4 times 4 to the 2nd power is the same as 4 to the 1st power times 4 squared. So when you're multiplying and bases are the same, you add the exponents. So this is 4 to the 1 plus 2, which is 4 cubed. We'll take a look at our second example, and we have 2n to the 4th power times 5n cubed. And remember, when you're multiplying, order doesn't matter. So I'm going to rearrange my numbers and write those numbers next to each other. And I'm going to rearrange the order of variables as well. So now I can just multiply the numbers, and 2 times 5 is 10. And multiplying bases, and it's the same base, so I just add the exponents. So this is n to the 7th power. So my final answer is 10n to the 7th power. Okay, on example 3, x squared cubed, or x to the 2nd power raised to the 3rd power. And we're taking the power of a power, so we multiply the exponents. So this means x to the 2 times 3, or x to the 6th power. Okay, number 4 is very similar to problem number 2. 6x squared times, 6w squared times 3w. We need to remember, if we don't see an exponents, it is 1. So the next thing I'm going to do is rearrange my numbers and organize those next to each other. So I have 6 times 3, and then w squared times w to the 1st power. And 6 times 3 is 18, And now I'm going to add the exponents. So 2 plus 1 is 3. So I have 18w cubed. Okay, the next example, I'm taking the power of a power. And so what I need to do is multiply the exponents. But if you remember, if you don't see an exponent, so in this case 3, it's 3 to the first power. So I'm going to do 3 to the 1 times 2, x to the 2 times 2, and y to the 5 times 2. So I have 3 squared, x to the 4th power, y to the 10th power. And I know 3 squared is the same as 3 times 3, which is 9, x to the 4th power, y to the 10th power. And that's our final answer. And on the last example, we're multiplying and bases are the same, so we add the exponents. So we have 3 to the 4 plus 5, which is 3 to the 9th power. Okay, so now we're going to look at a couple MCAS problems. What are the value of the expression? So we have a negative 2 cubed times a negative 2 squared. So I know that my base is negative in both of these factors because there are parentheses around it. So for the first one, I have negative 2 times negative 2 times negative 2. And for the second, I have negative 2 times negative 2. So if you think about this, when we're multiplying in bases of this, when we're multiplying, if there's an odd amount of exponents, our product is negative, and an even amount, our product is positive. So negative 2 to the 3rd power is an odd amount. So I know my product will be negative, and 2 times 2 times 2 is 8, times negative 2 times negative 2 is an even amount of negative signs. So I know my product will be positive, and 2 times 2 is 4. So when I take this product, negative 8 times 4, I get an answer of negative 32. So that means the correct answer is C. The last problem, what is the value of x that makes the equation true? Well, we're going to have to add the exponents since bases are the same. So x equals 5 plus 7, which means x equals 12. So I'd like you to take a second and write down what you think the key points of today's lesson are. And when you are done, you are welcome to go on to IXL and start practicing your multiplication and power of a power rule. Thank you for joining me.